Hey everybody, just wanted to go ahead and dive in. There's a lot of review and a lot of materials kind of going on this week, so let's go ahead and get started, all right? As it loads. All right, week 8. So this week we're going to be going over ambient air quality. There's some materials that we're going to go over again. The purpose of this weekly review is to give just a good general outline as far as important things to be able to remember, as there's always a lot of material in this class, as you all are probably pretty savvy with already. But hopefully I can be able to condense it down to the most essential information. There is a lot of reading and a lot of material, but we're going to be talking about that. So, housekeeping. It takes roughly about 6 hours to be able to complete all of these readings this week. I know that's intimidating, but we purposely designed that the assignments should be shorter and should take a little less time for that. And I would still encourage you, that's a daunting amount of time. However, my main purpose and what I'm trying to do with these videos as well is to give you some context, because then it's a lot easier to remember content when there's context. And so the very same, a lot of these other materials, we're looking at other videos and other presentations by whether it be Brother Benedict, that's a full-time staff faculty at BYU Idaho, or it's some regulatory installation that's talking about maybe a topic of some sort. So it's a lot, but hopefully it can be able to help solidify so that you're not having to just raw memorization of these keywords and definitions. Instead, you can apply these things and it can be able to help you remember a little bit more. So, introduction, ambient air. Ultimately, ambient air all has to do with the air that we breathe that is outside in the environment. I pointed to a window, it's out there. It differs than indoor air quality, which is inside of a house, inside your work, inside of any sort of building. So again, ambient air quality, outside air, indoor air quality, inside air. Should be fairly intuitive. And so it's important because the air that we breathe, it affects individuals differently. Just because I take a deep breath, and then someone else takes a deep breath, that air that we're breathing in and the various different particles that we can see and not see affect us differently. Just like whenever it comes to any sort of chemical exposure, everyone is affected by those things differently. And so it's important to be able to understand the ambient air environment, because that's something that, for the most part, we can't avoid and we can't escape. And it's going to take a lot more effort to clean that up necessarily than really any other activity. So again, this week we're going to be talking about ambient air, so outside air. Next week we're going to be talking about indoor air, so inside. And I will tell you, I'm excited for that one. Indoor air quality is possibly the bane of my existence whenever it comes to work, just because there's a lot of different factors, but we'll talk about that next week. So, what is ambient air quality? So, with this, again, there's a lot of reading materials, there's a lot going on. One of the best resources, and I'm not going to go over as far as an introduction, what is it, why it's important, or anything like that. I will actually leave that up to one of your reading assignments. One of the very first ones is actually a video presentation given by Brother Merle Benedict. So he is actually one of the full-time staff there at BYU Idaho on campus. He teaches this class as well, or he helped as well design this class, and he gives a very, very great explanation as far as what is ambient air quality, why it's important, what factors characterize. Review it. It is phenomenal. I also thought that the PowerPoint automatically suggested a hummingbird, so I thought that was perfect. So we went with that. Then as well, it's making sure to understand again. We'll go over material that he does not cover in his. Some of it will overlap a little bit. Some of it he covers and we cover. I just want to make sure to hit home. But I'm going to be mostly covering over material that goes after his presentation within the reading section. All right, ambient air quality. So ambient air quality, again, we can be able to illustrate that it is air that we breathe as humans, but it's outside. It's our outside everyday environment. And it's important to be able to understand there are many different causes of pollution that affects the overall quality of the ambient air. One of the primary sources of man-made air pollution actually has to come from automobiles and fossil fuel burning power plants. And typically automobiles, it also is due to that fossil fuel burning element of it. Even though we've gotten a lot better over the past couple of decades and really the past century by now as well on the combustion engine, it still can be fairly flawed, and it requires quite a bit of maintenance in order to make sure that it's running efficiently and not reducing the overall quality of our ambient air. So one of the biggest things with our ambient air that we're going to be looking at, especially in this class, has to do with what's known as criteria air pollutants. So in 1970, the United States adopted the Clean Air Act. This was the federal government's way of being able to help better control air pollution, especially in the ambient environment. A way that we could be able to also limit emissions and control emissions and, I guess, establish those emission standards for the general public to be able to follow, as well as manufacturers. Because that's a very big player, because ultimately, as the public, we are subject to whatever manufacturers design and create for the most part. We can usually sway how they build things and how they make things by what we choose to buy, but still it's a lot of it is up to them on what they're necessarily doing. But the 1970 Clean Air Act first established the National Ambient Air Quality Standards, or NAAQS. So what these are those emission standards. So specifically the NAAQS, when it first came out and even now, it illustrates 6 different criteria pollutants that are of particular concern by the EPA and the Environmental Protection Agency in the United States. Again, this is just United States focused. It's not accounting for anything else may be considered by the World Health Organization or other countries. But this one is just specific to the United States. The 6 different criteria air pollutants that we're going to be going over in this class include ozone, specifically ozone on the ground level, particulate matter, specifically particulate matter 2.5 and 10, carbon monoxide, lead, sulfur dioxide, and nitrogen dioxide. It's very important to be able to try to at least memorize these 6, that these are the ones that are in AAQS, that are those National Ambient Air Quality Standards. Just run through those, make sure to write them. Once you've written them, write them again. We're going to make sure that we understand that these 6, and these 6 alone, are those air quality standards. So now we're going to go into each and every single one of them and just give you a very good, just brief background on it that'll hopefully help supplement your reading as well. So ozone, otherwise known as O3, so 3 oxygens, shown in that picture there on the right, 3 oxygen molecules combined together is ozone. So one of the biggest things that is important to be able to understand is ozone, it's great in the atmosphere, but it's bad on the ground. So going into that a little bit more. So atmospheric, within the stratosphere, that's where ozone lies. So way up in the atmosphere, there's ozone that surrounds the Earth. And this ozone is very beneficial, actually. This ozone actually helps to block some of the harmful UV. So if you remember back in the first exam, UV, ultraviolet rays, that can be able to cause some forms of skin cancer. The ozone in the atmosphere can help protect us from a large majority of those UV rays that we're exposed to. Even within on the Earth, there's actually as well an ozone hole. That's been a big topic of global warming and climate change events, just having to do with there's a hole within the ozone that slowly gets bigger and smaller and bigger and smaller due to different sorts of events and as well times of the year as well. We're not going to go into that. You don't have to know too much about the ozone hole itself or anything, but just know that ozone in the atmosphere is actually a very good thing. But ozone on the ground level, that's where things get a little more dicey because ozone can actually be very harmful for humans and as well as other animals. So on the ground level, ozone can trigger several different health effects and so health problems, such as it can be able to, that should say, constrict airway muscles. So right here, on the top picture right here, that's actually a picture of your alveoli within your lungs. So your lungs and your respiratory system encompasses your mouth all the way down into your esophagus into your lungs. And then once you get into your lungs, you then breach into your bronchioles, and then your alveoli is the farthest deep down that you can be able to go. This is in your alveoli, that's where your oxygen exchange happens and occurs. That's important to be able to remember. Just that oxygen exchange occurs within the alveoli, within the lungs. It's the deepest part of the lungs that you can go. So one thing that overexposure to ozone has been able to see is that your muscles within your airways actually constrict. And whenever they constrict, it's like they're tightened, they're tensed up. It's like you're flexing your muscle. But whenever it's like that, air exchange, even if it occurs with your bloodstream, it's not able to get out. And so your blood, as it's coming, trying to look for more things, it still keeps on trying to swap out that oxygen, and it's not able to get the oxygen that it needs. And that can be obviously very detrimental to your overall health. In addition to that, ozone could be able to cause chronic exposure to ozone could be able to cause the onset of asthma, especially having to do with small children. You'll find that with almost every single one of these criteria air pollutants. Overexposure at a very young age can actually cause to asthma development within a variety of little kids. But again, it all affects us differently. Just because you have ozone in the air does not mean that you're going to develop asthma. Ozone is also related to just some severe coughing, some throat irritation, and as well as chronic exposure leading to chronic lung disease. That's a very important one to remember. That this one can be able to lead to chronic lung disease. Another important thing to be able to understand, again, having to do with that ozone hole, just more of a fun fact, rather, is that within old times, within aerosols, and even still today, there are some aerosols with it. Within aerosols, there was what was known as chlorofluorocarbons, otherwise known as CFCs. And inside aerosols, this helped to be able to projectile what was in the can itself. And that has actually been shown to actually dissipate ozone. You may be thinking like, oh, that might be, great to use as a control measure. Well, that is also not really the best because anything generated here could go up into the atmosphere, and we don't want to be disrupting that protective layer at all. So just a fun fact. You don't have to remember that at all, but just know that during the times of maybe like Grease or Hairspray, that movie, if you knew it, yeah, just definitely a lot of hairspray, a lot of things going on that Farrah Fawcett do almost. That was actually a big time that those aerosols could be disrupting and messing with the ozone layer. All right, so ozone continued. Wanted to be able to illustrate this a little bit. Is understanding that ozone isn't just how it comes about. One of the ways is that it can actually be formed from nitrogen dioxide, in addition to interacting with VOCs and also with sunlight. So the sun, again, that UV radiation, it can be fairly powerful for some molecules, and it can cause quite the interactions. This picture right here just demonstrates that further. It's the sun emitting UV rays onto an oxygen molecule. Oxygen typically is O2, so two oxygen molecules combined together. It's suggesting that the sun, the UV radiation, could be strong enough to hit that oxygen molecules and cause them to split. Well, a split oxygen molecule, an oxygen molecule by itself, is very unstable, and it doesn't like that. So one common thing that will actually lead it to is that it will buddy up and pair with the complete oxygen molecule. So a single oxygen molecule combined together with an O2 into O3. It's most um, preferred state. However, it's better than being alone. Is that it would rather be kind of grouped up together. It's kind of like that roommate if you've ever had them, and they would rather go out with you and your significant other rather than be alone on Friday night. Just be nice enough to them. They're not ozone. They're not hurting anyone. Just be nice. Okay, so another fun fact I wanted to be able to, or not fun fact, but another fun thing I wanted to be able to discuss is actually something recently that I'm tackling at my workplace. So what this is, this bottom picture right here, this is actually, there's a box on the wall, and this is actually an ozone generator. And it's an ozone generator that's found within a gym. That's at the location that I work. And within this gym, it's not very big, but within this gym, there are 6 of these ozone generators. Now you might be asking why? Why in the world is that even there? Well, whenever COVID happened, again, the worst thing about COVID was just how frantic people felt. Whatever your feelings are, I'm not discussing that or anything like it, but it was just the uncertainty that made things very difficult with the pandemic. And so this gym, they adopted these ozone generators, as ozone is a very good disinfectant. It's actually used in several different hospitals and different locations and meat processing plants to be able to disinfect the air, just to be able to help, again, reduce those foodborne illnesses that we just talked about. They can be able to help the potential spread of that bacteria. This gym decided to adopt those ozone generators during the pandemic to be able to help out, and therefore they could open sooner, because they were losing money. They were losing money. It makes sense from that end. So these are, again, commonly implemented in offices and other public areas, meat processing plants. However, it's important to understand that, again, ozone, it harms us. It has that potential. The TWA, if you remember what that TWA, time weighted average, so it's about an 8 or 24-hour period. So for example, all these are 24-hour period limits that have been set. The EPA actually suggests that you should not be exposed to ozone for an average of 0.08 ppm, meaning parts per million within the air. You should not be exposed to more than that. So it's a good frame of reference. Oh, well, no, that won't be very good. Never mind. So OSHA, it actually says 0.1 ppm. And the ACGIH TLV, so that stands for the American Conference of Governmental Industrial Hygienists, that's their threshold limit value. It's not a regulatory limit by any means, but they take modern research and they apply it to then be able to see, okay, what do we suggest based upon modern research on what someone could be exposed to and still not be affected too bad. So they actually split it up into 3 different categories. If you're performing heavy work, so just having to do with a lot of respiration, moderate work, and light work, 0.05 ppm, 0.08 ppm, and 0.1 ppm. So they actually agree very similar with OSHA. As far as if you're performing light work, yeah, ozone, it's not going to be that bad. But if you're performing heavy work, 0.05 ppm, they're saying there should be some concern there and it could impact their health. Well, anyway, I go to this gym actually all the time, and I actually look at this monitor every single time because this ozone generator has this little box monitor on the right that displays what is the average ppm at that present time. And so right here, that's what the right picture is. Just zoomed in super close to be able to show you 0.031 ppm. So that's a little over half. And so my first thoughts whenever I was hearing this, one, I thought it was a bad idea, just because you're knowingly subjecting individuals to this, especially nowadays where the COVID threat is definitely a lot lower than what it was. We're petitioning them to take these out because the risk outweighs the benefit in this way, especially as here in Utah, the overall ambient air quality is not really the best during most times of the year anyway. But going back to it, these were the readings: 0.01031, But again, that's well below any of those limits that we were talking about. However, it was better understanding, okay, well, what's the population? And this is what I do for work every single day, is looking at what are exposures and then what are any limits or things to be able to help better protect the public and employees and companies. And it was understanding that, well, this is a gym that is frequently visited by individuals that are actually 60 years old and older. So ozone, it can be able to affect the respiratory system. It can cause that constriction of muscles, and it can cause difficulty in breathing. And over a chronic term, it could be able to potentially do some damage. The most frequent customer of this gym specifically are individuals that are retired, typically 60 years old and over. So with that, it was taking into account if they're really working out and they're really, really going at it, that heavy work limit and this limit, that can actually introduce some problems just because this clientele may already have limited lung function just due to anything else, and then being exposed to something equally as bad outside into the environment. We're still working with them actually, but just wanted to share a fun fact of ozone within the workplace, how this is relevant. This is actually something I've been tackling in the last year or so. Anyway, let's keep going. Tangents, I love them and I can't get away from them. Next, criteria air pollutant, particulate matter. So it's important to be able to understand particulate matter, otherwise known as PM. Particulate matter is a general term. So it just means particles of various compositions. It could be anything, dust, dirt, soot, smoke, solid particles, liquid particles. Typically anything could be considered particulate matter. Really, the biggest things that we're concerned with are those very, very fine and ultra fine sizes whenever it comes to particulate matter. But particulate matter, it could be able to result in grime on solid surfaces. So if you ever go outside and you look at your car and it's just got this filth on it, but you're not really sure what it is, it's not like pollen or anything, particulate matter. It's just stuff that's there. So the two ones that we're primarily concerned with are PM10, which is particles that are 10 micrometers and smaller, and PM 2.5, which is particles that are 2.5 micrometers and smaller. And that PM 2.5, that actually poses the greatest risk to human health, just because the smaller those particles get, the deeper in the respiratory system that they're able to go. Again, clogging up those alveoli. If those are clogged up, that oxygen exchange is not able to happen, and it can be very detrimental towards human health. This picture here on the side just illustrates how small are we talking about? Like how small really is, PM10 or 10 micrometers and 2.5 micrometers. As we're looking at this, we can be able to see they have a picture of fine beach sand, which is about 90 micrometers in diameter. Then it also shows a human hair. So human hair, roughly about 50 to 70 micrometers in diameter. So think about how small one piece of your human hair is. And then now divide that by 5. That's PM10. As dust, pollen, mold, all of these things are just 10 micrometers or smaller. And then we get down even further into PM 2.5. So again, a fourth of even the size of pollen itself. That's gosh dang it, I can't do this math, but it's almost 20 times smaller than your human hair. It's hard to even fathom this, how small these particles are, but it can help you be able to better understand it, how big of an impact they can have and how deep in your lungs they can be able to go. This is typically stuff you're not going to just cough out on your own, or that your nose hairs are going to be able to catch for you. These things could be able to include combustion particles, organic compounds, metals, etc. So some of the biggest risk factors whenever it comes to particulate matter exposure actually come from construction sites, unpaved roads, and also just fires, whether that be a wildfire or even a controlled fire that maybe you built on your own. But inhaling that smoke is definitely a no bueno idea, as it can be able to inhabit a lot of these materials that can affect your overall health. So particulate matter continued. So the EPA has set NAAQS for PM10 and PM2.5. So that's actually a very big distinction, is that this is the only criteria air pollutant that has two standards for the one substance. Because again, it's particulate matter as a whole, but it has to do with the size. And each of them have a separate NAAQS for them. So PM10 for its 24-hour average of about 150 micrograms per cubic meter. Just know in general that that's not a lot. It's really not. And then we go into PM 2.5, an annual average of about 35 micrograms per cubic meter, a 24-hour average of 9 to 10 micrograms per cubic meter. I'm not expecting you to memorize these numbers itself. Know that there are separate standards for 10 and 2.5. You don't have to memorize 150, 35, 9 to 10. I don't believe that's of any importance for this class, but just know that there are separate standards. But one thing that is super relevant is how recently the PM 2.5 24-hour standard actually has changed. It's January 6th, 2023. Again, my purpose is to show you how relevant this information is. The EPA has actively just looked at this. So EPA, again, the Environmental Protection Agency, that's the picture there on the right, they just adopted their newest 24-hour standard for PM 2.5. And so the last time that something changed was 2012. And so since then, thousands of new studies have been looked at, particularly having to do with soot, to be able to look at how does this impact human health, and specifically the respiratory tract. So previously, it was 12 milligrams per cubic meter. So it was 12, now it's 9 to 10. And so it's 9 to 10, it's a range because it just varies depending on some other factors. But 12 to 9 to 10, that's not a lot. It's 2 to 3 milligrams per cubic meter. That may not sound a lot, but perspective is key. So what is the EPA predicting that this reduction will be able to benefit? What will it prevent? What will it help? The EPA is suggesting that this reduction will prevent up to 4,200 premature deaths every single year. That's insane. That small of a change can invoke that big of an outcome as well. 270,000 lost work days per year. They're suggesting that if we lower this standard and people are complying with this standard, people will not be as sick, and therefore lost work days will reduce by 250,000 work days. That's insane. That's incentive enough for also companies to be able to buy off on this. Can be beneficial if we can reduce it this much. The EPA is saying that this will result in roughly about a $43 billion net health benefits in 2032. So in roughly about 9 years, $43 billion benefit. So again, you don't have to memorize any of this. This is all just bonus information. Again, the only important thing that we're able to understand is that outlined right there. That's why I outlined it. Underlined it, not outlined. Underlined it. The EPA has set separate NAAQ as PM10 and PM 2.5 standards. It's the only one that has two different standards for the same substance. I just wanted to illustrate it again, context-wise. This is relevant and this is important right now. They just reviewed it. And so it's something important to be able to understand, or at least have a working knowledge about. Next, criteria air pollutant, carbon monoxide, otherwise known as CO, probably otherwise known as Gary. I don't know what it calls itself. But carbon monoxide, we probably all heard of this in some way, shape, or fashion. So it's a colorless and odorless gas. It is typically released because of incomplete combustion. That's almost one of the only ways that we find it in the natural environment, is whenever man-made fossil fuel burning combustion engines naturally produce carbon monoxide. Combustion engines produce a lot of different stuff. That's why it's the leading source of man-made air pollution. But carbon monoxide, almost the only way that we find it is from a combustion engine. And it happens because of incomplete combustion. So if something combusts completely, it's gone. There's nothing left. All of the molecules have been transferred and converted into energy to then make the engine go. But incomplete combustion means something went wrong. It was able to combust, however, not all of the materials, the matter, is gone. And so, if there is a flame, if there's anything burning, there is carbon monoxide because incomplete combustion happens all the time. If you have a candle on just your table or your nightstand, I do not suggest that, by the way. If you have a candle, there is incomplete combustion happening actively right there. Is it going to be a lot? Is it going to be a lot of CO? No, it's not. It's not. But it's important to be able to understand that if there is a flame, carbon monoxide is being generated. Some of the health effects. So what is carbon monoxide? What does it do? So it is actually able to reduce the amount of oxygen delivered to our brains. So again, thinking about the respiratory system. So enters in through our nose and our mouth, travels down into our lungs, into our bronchial tubes, into our bronchi, and then into our alveolar sacs, or alveoli sacs. So that's where that blood oxygen exchange happens. And so what happens is that whenever we inhale carbon monoxide, this picture illustrates it as well. If we're inhaling carbon monoxide and oxygen at the same time, and it travels down into our lungs, into our alveoli, and right here it's illustrating that our hemoglobin, so our red blood cells, their job is to carry oxygen to different parts of the body. So whenever oxygen is meant to go in, attach to the hemoglobin, and then go into it, that's oxygenation, go into every single part of the body. CO can also transfer over and attach to that hemoglobin, and therefore, whenever that blood makes it up to our brain, it's not depositing oxygen. It could potentially be depositing carbon monoxide, or at the very least, it's not letting go of anything. And therefore, that hemoglobin is now useless, as that it has that strong connection. Because our hemoglobin actually, the way that it views carbon monoxide is it views it almost like ice cream. Okay, if you really like ice cream, you don't think of any other snack or treat that you want. We know that we need a good healthy dinner. However, ice cream sounds fantastic. Always. Ice cream always sounds fantastic. So the hemoglobin comes down, and if there's too much CO and O2 that's available, sometimes it would rather latch onto that, or it would rather take a bite and hold on to that ice cream rather than its actual dinner. And so whenever it gets up, it actually is not depositing oxygen. Therefore, different systems throughout our body is not getting the oxygen it needs. Exposure to carbon monoxide could result in dizziness, confusion, unconsciousness, and death. Carbon monoxide as well, just like we were talking about the very first exam, is an ototoxin. So an ototoxin, again, it affects our hearing. So specifically, it's chemicals that affect our hearing, even whenever there's no loud noises to begin with. And we can kind of be able to understand that. Again, it's our ear hairs that detect those vibrations within our cochlea to then send an impulse to our brain so that we can understand what a noise is and what's going on. But if we're not getting an appropriate amount of oxygen up into those ear hairs, they're not working well and they're possibly going to die. Therefore, we could lose our hearing. Just another application. You don't need to know it's an ototoxin, but you do need to know that carbon monoxide, it's there, it's present. If there's a flame, there is carbon monoxide present. It occurs through incomplete combustion, and it messes with that oxygen delivery to the brain and other systems. So next, we're going to go into the next criteria air pollutant, lead. So we've gone over lead quite a bit. So lead, it's a metal. So you may be asking yourself, well, if it's a metal, how in the world is it getting into the air? I'm not, licking it or anything like that. Well, in that case, good question. And don't lick lead. Typically, lead is pushed into the air due to a variety of different processes. Metal ore processing, waste incinerators, lead acid battery manufacturers. I had the opportunity to tour a lead acid battery destruction group. I can't tell you where it was, but anyway, they're the only one in the country and one of only a few in the entire world. But the lead is a particularly high concern there, inhalation wise, just due to that fact alone. So whenever it comes to lead, another very big exposure that used to be, I believe it was prior to 1970. So again, or it might have been 1980, a big push on it. Either way, earlier on, 40 to 50 years ago, there was as well leaded gasoline. So this may kind of make sense right here on the bottom right picture. There's a picture of just like you go stop at a gasoline pump. It always says mid-grade, unleaded, premium unleaded, low-grade, unleaded, something of that sense. But unleaded, yeah, it is literally telling you there is no lead in this. And it's been telling you all this time. It's because this used to be a problem. We used to put lead inside of gasoline. And that was a big issue. Again, whenever we're running things through a combustion engine, not everything is blowing up the way that it should. And therefore, it is expelling and atomizing that lead into inhalable particles. That was a big issue, and it's still even a big issue today in some developing countries as they're still using leaded fuel. And we even still use leaded fuel in some different operations as well. But that's what that top right picture is, just a really, really old gas station, possibly using leaded gasoline. So the largest impact on reducing lead in the air was actually that change from leaded to unleaded gasoline. So roughly from this, after it was changed, from about 20, I don't think that's right. I think it's supposed to say 1978. Either way, during only about like a 20-year period of time, the amount of lead that was just present in the ambient environment reduced by almost 98% just from taking lead out of gasoline. That's huge. And remember that, hint, hint. The largest impact on reducing lead in the air involved taking lead out of gasoline. Okay, another effects of lead is being able to understand. You may remember again earlier on in the semester, one of the biggest things, lead causes mental problems in children. So that's of course a very big concern that the general public has in being able to reduce the ambient lead out in the ambient air. Also, an additional thing is chronically is lead-induced osteoporosis. The only reason I'm talking about this is because I think it's a fun and an interesting thing. If you remember only one health effect, remember that it causes health problems in children. Remember that. But lead-induced osteoporosis is a fascinating kind of topic as well. So this picture right here, there's a normal bone structure, and then osteoporosis, what it is. Yes, you can be able to see the holes are a little bit bigger, and it actually causes a weakening of the bone itself. So why is that? This is actually, or some of this is due to lead. Lead can actually cause this weakening of the bones itself. So within our bones, if you've taken a microbiology or an anatomy class, you've heard about transfer channels. Lead actually will mimic different molecules within that transfer channel and place itself there. But it doesn't, it's a key that doesn't belong in that lock. So therefore, the transfer is not able to actually occur, even though lead fits in perfectly. So what is that transfer blocking? It's blocking the bone from being able to properly uptake calcium. And so if it's not able to properly uptake calcium or different other vitamins such as vitamin D and vitamin A, then it's not able to get the structural components that it needs to be able to maintain its structure, its integrity. And that's whenever osteoporosis can be able to occur over a long period of time. So just a fun fact, again, you don't need to know about osteoporosis, know about mental problems in children. I'm just wanting to illustrate contextually why this is important, and hopefully some things to be able to remember. All right, next, sulfur dioxide. So we're a little over halfway through these, so pause it, take a break, come right back to it. Sulfur dioxide. All right. Sulfur dioxide, otherwise known as SO2. So in that bottom right picture, SO2 just refers to one sulfur molecule attached to two oxygen molecules. This is the largest source of the largest source of sulfur dioxide pollution comes from fossil fuel combustion at power plants. So again, that fossil fuel combustion, but this one specifically at power plants. Another important thing is understanding that sulfur dioxide is a precursor for acid rain. We're going to talk about acid rain here in a little bit, so I'm just going to move past that, but know that sulfur dioxide is linked to acid rain. Sulfur dioxide in the ambient air also can be able to generate sulfurous smog, otherwise known as London smog. So this occurs from burning of fossil fuels, particularly coal. If you remember during the time of like Oliver Twist and everything, movies typically illustrate like that there's similar to this picture up here in the top right, a general yellowish haze over everything. And that has to do with that continual burning of fossil fuels and coal. It's releasing sulfur into the environment, specifically sulfur dioxide and other sulfur oxides. But remember that the important one to remember is sulfur dioxide. That's the criteria pollutant. Sulfur oxide or any other form, not a criteria air pollutant. Sulfur dioxide is. Health effects that could be able to include lung irritation, specifically those that already have asthma, and it could lead to the development of asthma as well. Okay. Next, we're going to be talking about another oxide, nitrogen dioxide, so otherwise known as NO2. So sulfur dioxide, SO2, nitrogen dioxide, NO2. So this is the most dangerous of the nitrogen oxides. But it's important to be able to understand this is different than nitrous oxide, nitrogen hydroxide, and nitric acid. All right? Those things can be dangerous. But nitrogen dioxide is the most dangerous of the nitrogen oxides. So the other oxides, those are not criteria air pollutants. The only criteria air pollutant, nitrogen dioxide, NO2. So again, very similar to sulfur dioxide, this is one nitrogen atom or molecule combined with two oxygen molecules. So this primarily gets into the air by burning fuel, similar to sulfur dioxide. It is also a precursor for acid rain, and it also creates what's known as photochemical smog, otherwise known as a reddish-brown haze. So you can be able to see that in the top right picture. Instead of that yellowish look that sulfur dioxide does, this one is a much darker, deeper brown color. That's that photochemical smog. So why is it called photochemical? Great question. So this can be able to react with different materials to be able to form O3 and other forms of particulate matter. This picture down here on the bottom right just illustrates it further. As these cars are driving, they're naturally kicking out nitrogen dioxide through incomplete combustion. And so as this nitrogen oxide is coming up, or nitrogen dioxide is coming up, it is interacting with the sunlight. We already know that the sun can be able to influence and actually has enough energy to be able to change some molecules on its own. Nitrogen dioxide and sunlight can mix together, creating this brown photochemical smog. That's why we see in a lot of different areas that have topographical areas. Brother Benedict, he talks about this in his, again, look at it. It is very important, and there's items to be able to understand on his presentation. But the one I will speak to is topographical areas. So where mountains and valleys and ranges are, all those heavily influence criteria air pollutants and ambient air quality. So in areas such as Los Angeles and also even in the Salt Lake City Valley, you get a lot of buildup of smog, mostly because it's a valley and it sits in there, and it's really hard for that air to be able to pass through and move on its own, and it kind of settles right there in the city area, especially where there's very high traffic. But moving forward, So nitrogen dioxide and sulfur dioxide create, and they are precursors to acid rain. Most likely you've heard of acid rain before, but we're going to go into it a little bit more. So NO2, nitrogen dioxide, SO2, sulfur dioxide, they can react with water in nearby clouds, mostly being able to attach to it almost in a sense. And so this picture illustrates that a little bit further. As natural evaporation of water happens, it rises up into clouds. It's part of the water cycle. It all rotates. If you would like, spend some time understanding the water cycle. You don't have to, though. As factories and combustion engines are occurring that cause NO2 and SO2 to be able to escape into the ambient environment, it is taken up by that evaporation process into the clouds and kind of joined together with that water in those clouds. Whenever the cloud actually starts raining, it gets too heavy, it starts going out, that's whenever it can be able to actually rain sulfuric acid and nitric acid. And it can be able to fall on a variety of different areas. You may be thinking like, well, what's really the problem? Well, it's raining acid, so that's not good. But it also, one of the primary harms is that it can be able to damage plants and trees and also buildings and different structures. So it can raise the acidity within the soil. And if plants and other things can be very finicky whenever it comes to their soil, it's literally their biggest source of nutrients and food. And so that can cause the plant to be able to die over a long period of time. That's not good. Same thing, there are different materials that might be made from calcite minerals. So for example, limestone and marble. I wanted to find a picture. I guess I didn't. It can actually start degrading some of those materials itself as they're not very resistant to acids. So it could not only affect structural integrity, but it just hurts the general environment around us. So reducing nitrogen dioxide and sulfur dioxide is a big top priority just because they have this interaction with acid rain. All right, so we talked about the 6 criteria air pollutants. Now we're going to talk about, again, one of the biggest sources that we have from it come from automobiles and fossil fuel burning power plants. That's the main source of man-made air pollutants, come from those two objects. So we're going to start talking about some things that we've adopted and we've implemented into automobiles to help reduce the amount of pollution that is kicked out to it. It doesn't get all of it, but it's been able to reduce it tremendously. So the main players, whenever it comes to the overall emission system within your vehicle, include oxygen sensors and the catalytic converter. So oxygen sensors, they're these little diodes that could fall anywhere along this entire stretch. So this picture right here on the right just illustrates from the engine itself. It goes into the exhaust, any sort of byproduct from the combustion itself, goes and enters into the exhaust manifold, goes through exhaust pipe into the catalytic converter, into the muffler, and then out the backside of your car and your vehicle. And so the oxygen sensor, what it does is it's monitoring throughout this entire process as a good ratio between oxygen and fuel can be able to increase how well that combustion is actually occurring. And so you want to make sure that your oxygen ratio is going well, because then that combustion can happen accurately. Therefore, less pollutants are actually being kicked out. Then your catalytic converter. This is a very, very important part because this acts basically as your filter for the emissions through conducting both reduction and oxidation reactions. Okay, so catalytic converter. So the catalytic converter, wait 1 second. Yeah, all right. It was telling me that it switched off, but yeah, catalytic converter. It was introduced into American cars produced after 1975. And the EPA regulations sought to be able to reduce vehicle emissions by 75%. So American car producers, they implemented the catalytic converter. The catalytic converter is a pathway and is a unit that's made up of three different precious metals: platinum, palladium, and rhodium. These precious metals, these could be hundreds and hundreds of dollars worth. And these are very important as they help to be able to transfer some of these materials into less hazardous materials, from these pollutants into less hazardous materials as they exit the exhaust. It's actually fascinating. In fact, whenever we're in Texas, these things can be so expensive that there would be times that we left our car to go into Walmart. And whenever we come out, there was someone sitting in the parking lot waiting to tell us, like, hey, just so that you know, whenever I pulled up, there was someone underneath your car. I scared them away, but I think they were going after your catalytic converter. And we looked under, nothing was fine. It looks like they got there in time, but it's very, very common. Sometimes thieves will specifically go after the catalytic converter. They'll just go up and they'll saw it off just with a hacksaw, just so that they can be able to take it off and then sell it for scrap because of these three precious metals. Anyway, fun fact, it is expensive, so it's important to be able to understand that and remember that hint. So the catalytic converter, just like the name suggests, it acts as a catalyst to lower the energy required for reactions to occur. So again, that's the whole purpose of a catalyst itself, is usually it takes this much amount of energy or this much amount of energy for a reaction to occur. Having a catalyst, having an appropriate catalyst now requires that much energy. Very beneficial if you can have the right catalyst. That's why the catalytic converter was introduced, so that a chemical reaction can occur and change those pollutants from harmful to less harmful. Now let's look at that. All right, catalytic converter, how does it work? So there are three specific ones that are important to be able to remember. So again, catalytic converters, they bring about reduction and oxidation reactions. So the very first one that we're going to look at is a reduction reaction that turns nitrogen oxides into nitrogen and oxygen. So again, a reduction is, you can think reduction that you're reducing it, you're breaking it down. So it's able to take NOx, and that's what the picture underneath, there are three pictures. I tried to type these out, but for some reason PowerPoint doesn't like superscripts or subscripts. So I just found a picture and put it in there. Reduction reaction of nitrogen oxides, so including nitrogen dioxide, can be actually split apart those molecules and cause them so that now it's just nitrogen and now it's just oxygen released into the environment. And that's a lot better state, because we breathe in nitrogen and we breathe in oxygen all the time. It's just whenever those two are combined that's whenever some issues arise. So that reduction reaction of nitrogen oxides, specifically nitrogen dioxide, the catalytic converter allows that to happen. Next is the oxidation of carbon monoxide into carbon dioxide. So if you remember carbon dioxide, we deal with that all the time. It's still not the best for us, but I was actually exposed to carbon dioxide there and I survived. That's the same thought process. So oxidation actually is the introduction of oxygen. So you can think of reduction as reducing, taking away. Oxidation is bringing together or combining, adding two substances, or a substance with oxygen. So oxidation, oxygen addition. So carbon monoxide, if they can be introduce oxygen to it, and it's because of those precious metals, the palladium, the platinum, and the rhodium, that allow this transfer to be able to occur, it can transfer carbon monoxide plus oxygen into carbon dioxide. Very similarly, oxidation of a hydrocarbon into carbon dioxide and water. So CH4 in this picture, that's just a hydrocarbon. So that's just another VOC byproduct of a combustion engine that can be able to occur. With the introduction of oxygen, so again, that's why those oxygen sensors are very important, because they help with this process and converting these elements together into less hazardous ones. It can be able to create now less harmful carbon dioxide and less harmful water. Still wouldn't want to drink it, but water in general is less harmful. And that is it. That's it for this week. Definitely, again, review and look at those readings. There's a bit, and I apologize for that. However, the assignments hopefully will be reduced, and you'll kind of better be able to manage it. But hopefully, this has been able to help, and hopefully, it helps from a contextual standpoint. Again, I hate it whenever, not that I'm blaming any of you, but I feel discouraged whenever I am introduced to something that I just have to memorize. But if I can be able to conceptualize, it helps me to be able to remember and why this is important. So hopefully you have a good rest of your week. Let me know if you have any questions, and I guess I will see you later.